Okay, last video for this section is going to be your logarithmic. We're going to start with these exact values. I told you in class, it's hard to kind of conceive of a log. Like this answer I know is 2 because 5 squared is 25. You can think about a log that way, but sometimes it's necessary to instead set it equal to x and rewrite it as an exponent. So this is going to be 5 to the x is equal to 25. 5 to the x is equal to 5 squared, so x would have to be 2. This, this is actually log base 10, and I say this is equal to x. 10 to the x is equal to 10,000. 10 to the x is equal to 10 to the third, actually it should be 10 to the fourth power, shouldn't it? So x is equal to 4. Log base 6 of 6, this is going to be 1, I know, but you can write it as 6 to the x is equal to 6, which is 6 to the x equals 6 to the first, so x would be 1. This one here is log base 1/2 to the x is equal to 16. I changed both bases. This is going to be 2 to the negative x is equal to 2 to the fourth power. Negative x is equal to 4. X is equal to negative 4. Remember that the natural log is log base e of the fifth root of e, which I can also rewrite as a log base e of e to the 1/5 power is equal to x. My base is e, my exponent is x. This is equal to this whole thing, your index, which is 1/5. So x would have to be 1/5. This right here would be 9 to the x is equal to 3. Okay. 9 is actually 3 squared, so this is going to be 3 to the 2x is equal to 3 to the first. 2x is equal to 1, x is equal to 1/2. This next one, 6 to the x equals 1. But remember, anything to the 0 power is 1, so x must be 0. And that's our answer there. This is equal to 0. This one's equal to 4. This one's equal to 4. That one's equal to 1. That one's equal to 1/2. This is 2, or this should be equal to x. 2 to the x is equal to 1/16. 2 to the x is equal to 2 to the fourth. Sorry, this should be 2 to the negative fourth. So x must be equal to negative 4. Let me just backtrack a little bit because I think that might be confusing. 2 to the x is equal to 1 over 2 to the fourth. 2 to the x is equal to 2 to the negative fourth. X is equal to negative 4. And this one is log base 10 of negative 5 is equal to x. 10 to the x equals negative 5. This actually has no solution. Alrighty, let's go with our condensing and whatnot. For this, you always work with parentheses. Always bring your exponent up first. So this is 1/3 log base 7 of 64 plus log base 7 of 27 squared. Don't worry about big numbers quite yet. I condense even further because addition becomes multiplication. So this is log base 7 of 64 times 27 squared. This then becomes log base 7 of 64 to the 1/3 times 27 to the 2/3. So I brought this exponent up to both terms. Log base 7, 64 to the 1/3 is the cubed root of 64, which is 4. And then 27 to the 2/3 is the cubed root of 27 squared, which is 9. So this ends up being log base 7 of 36. Next guy here, I change it to multiplication, so this is going to be the natural log of 64 times k minus the natural log of m to the fourth, because I bring that up. It's the natural log of 64 to the 1/2, k to the 1/2, minus the natural log of m to the fourth. Square root of 60, so keep going. It ends up being division, so this is the natural log of 64 to the 1/2, k to the 1/2 over m to the fourth, which ends up being 64 to the 1/2 is 8, k to the 1/2 over m to the fourth. Next one, I bring up my exponent, so this is going to be log of x minus 4 squared plus the log of 3x. I'm actually going to rewrite this. I'm going to FOIL it out. This should be x squared minus 8x plus 16 plus the log 3x. This ends up being the log of x squared minus 8x plus 16 times 3x, the log of 3x cubed minus 24x plus 48x, 4x squared plus 8x. Next thing, natural log of 25 to the 1/2 plus natural log 7, natural log of 25 to the 1/2 times 7. Well, 25 to the 1/2 is 5, and 5 times 7 is 35. This one right here, this is going to be the log of 42 over 6. This next one, we're working backwards. How could I write this with a 4? So the natural log of 16 is actually a natural log of 4 squared, and we would drop this out front, so there should be a 2 here. This other one, this is the log of 53 to the 1/4 power. So this is 1/4 log 53. So this is going to be 1/4. So expanding. So first thing when I have division is I separate with subtraction. So this is log base 4 of 3a to the 7th c minus log base 4 of 5. This can be separated further. This is log base 4 of 3 plus log base 4 of a to the 7th plus log base 4 of c minus log base 4 of 5. And then I drop my exponent, so this is log base 4 of 3 plus 7 log base 4 of a plus log base 4 of c minus log base 4 of 5. This one, first I would drop the exponent, so this is going to be 3 log 5 radical u over w squared. Okay, then I keep the 3 and I separate division just like I did before. Log of 5 radical u minus the log of w squared. Separate again, 3 log 5, so 3 times the log of 5 plus the log of radical u minus the log of w squared. 3 parentheses log 5 plus, now this actually is u to the 1/2 power, so I'm going to drop the 1/2, log u, 2 log w, because I dropped my exponents. So the last thing is 3 log 5. This should be minus, sorry, dropped that sign. Plus 3 halves log u minus 6 log w. I have a typo here. I have this twice. It says the natural log of z is equal to the natural log of y plus 2 minus 2. And it says we're going to rewrite it, z in terms of y, so it's just going to be z is equal to. So the natural log of z, if I condense this, is, so I do, this should be 2 natural log y. Okay, here we go. So the natural log of y plus 2 minus the natural log of y squared. The natural log of z is equal to the natural log of y plus 2 over y squared. So z must be equal to y plus 2 over y squared. Find the inverse. This was just kind of interesting rewrite. So when you find the inverse, you switch your x and your y. So this is x is equal to 2e to the y plus 3. If I were solving this, I would divide by 2. So this is x over 2 is equal to e to the y plus 3. Once I have this, I can take the natural log of each side. Natural log of x over 2 is equal to y plus 3. And so my answer is going to be the natural log of x over 2 minus 3 is equal to y. And that's our inverse. Okay. Now we're going to get to solving. These ones are pretty easy. Like if I have log equal to log, it's going to be 3x squared plus 4x is equal to 2x squared plus 12. I just set the insides equal to each other. So if you can, you want to get it to be, you want to condense it to that point, so it's that way. Subtract 2x squared, subtract 2x squared. So this is going to be x squared plus 4x is equal to 12. I subtract 12. X squared plus 4x minus 12 is equal to 0. I can factor it. It's going to be x plus 6 times x minus 2. So x is either negative 6 or x is equal to 2. Now I have to make sure that I check it. Make sure you check in here. If you look at this, even the negative 6, that's going to gives positive answers. Okay, we have to look out for negative logs. Okay, next here, if we can make it look like this one over here, then that would be good. I know that this becomes division, so this is going to be log base 9 of 12 over k minus 5 is equal to log base 9 of k plus 6. Okay, I set them equal to each other, so it's 12 over k minus 5, because subtraction becomes, to condense a log, to make it one log, becomes division. Is equal to k plus 6. I multiply each side by k minus 5. This ends up being 12 is equal to k plus 6 times k minus 5. 12 is equal to k squared minus 5k plus 6k minus 30. 12 is equal to k squared minus 5, or plus 1k plus k minus 30. Subtract 12, 0 is equal to k squared plus k minus 42. This is going to be k plus 6 and k minus 7. There we are. k minus 7, and k plus 6 is equal to 0, so k is equal to 7. If I plug that in, 7 does work. So 7 minus 5, the log of 7 minus 5, that's going to be the log of 2, so that works. And then if I do the log of 7 plus 6, that's going to be the log of 13, so that's okay. The next one, our next answer is k is equal to negative 6. If I plug that in here, that's going to be the log base 9 of negative 6 minus 5, which is log base 9 of negative 11, which we can't have. And then we'll also have log base 9 of negative 6 plus 6, which is log base 9 of 0, which we can't have either. So this is extraneous, so your answer is k equals 7. Last page, woohoo. So here, this is weird, I don't have my parentheses here. This one's a little bit dicey. So I know I can rewrite this because I want to condense my logs first. This is going to be 5c minus 9 to the 1/2 power. Don't stress out about that too much. And this is going to be log base 5 of 3 times 2, so log base 5 of 6. So same thing, if I have a log and a log, it's going to be 5c minus 9 to the 1/2 power is equal to 6. Now, how do I get rid of the 1/2 power? I can take everything to the second power, as long as I do it to both sides. So this is 5c minus 9 is equal to 36. 5c is equal to 45. c is equal to 9. If I substitute this in, this is okay here. So we're good. Okay. So let's get to the next one. Anytime you're solving a logarithm and you have a number on one side, you try to get it by itself. So I'm going to subtract 2. 2 is actually negative 6/3. So this is going to be the log base 8 of 7 minus 5w is equal to 5/3. When I rewrite that, so whenever it's equal to a number, change to exponential. Okay, so this is going to be 8 to the 5/3 is equal to 7 minus 5w. 8 to the 5/3, it's the cubed root of 8 to the 5th power. Cubed root of 8 is 2. 2 to the 5th is 32. 25 is equal to negative 5w. W is equal to negative 5. It does work up there, so we're good. And this, yeah, that would definitely work. Number 18. Condense, condense, isolate, and then turn to an exponential. So this is going to be the natural log of 2r minus 3 plus the natural log of 9 to the 1/2 power is equal to 7. Natural log of 2r minus 3 plus the natural log of 3 is equal to 7, because 9 to the 1/2 power. This is the natural log of 3 times 2r minus 3 is equal to 7. The natural log of 6r minus 9 is equal to 7. Remember that this is a log base e, so this is e to the 7th is equal to 6r minus 9. E to the 7th plus 9 is equal to 6r, and r is equal to e to the 7th plus 9 all over 6. Again, always first get your log by itself. So this is 3 log 6, 2h squared minus 14h is equal to 6. Divide each side by 3. So this is log base 6 of 2h squared minus 14h is equal to 3, or is equal to 2, excuse me. There we go. I rewrite this as an exponential, so this is 6 squared is equal to 2h squared minus 14h. 36 is equal to 2h squared minus 14h. 0 is equal to 2h squared minus 14h minus 36. I take the greatest common factor, that's going to be h squared minus 7h minus 18. And do a little bit one of those. This ends up being 0 is equal to 2. This is h minus 9 times h plus 2. So it's either h is equal to 9 or h is equal to negative 2. When I plug into the original problem, both are positive. And you always check in this right here. So this would be like 2 times 9 squared minus 14 times 9. That has to be greater than 0, and it is. And then you'd also do 2 times negative 2 squared minus 14 times negative 2. That has to be greater than 0. This is not the calculator section, so ignore that. First thing, I would just leave these, so minus 5, minus 5. So this is 7 times 9 to the 2r plus 7 is equal to 15. Divide by 7, divide by 7. 9 to the 2r plus 7 is equal to 15 sevenths. I'm going to take my log base 9, and then this will be log base 9 of both sides. Why base 9? Because log base 9 and 9 are basically inverse operations, so I end up with 2r plus 7 is equal to log base 9 of 15 sevenths. This is just the easiest way. I would subtract 7. So this is going to be 2r is equal to log base 9 of 15 sevenths minus 7. And then I divide by 2. And so r is equal to log base 9 of 15 sevenths minus 7 over 2. Last one, I'm just going to take the regular log of each side. So log of 2, 5 minus x is equal to the log of 5, 2x plus 3. You could take those bases, but it ends up being pretty much the same number of steps. I drop my exponent. This is 5 minus x. Log 2 is equal to 2x plus 3 log 5. 5 log 2 minus x log 2 is equal to 2x log 5 plus 3 log 5. So we're just doing distributive property, it just looks a little backwards. I get all of my x's on one side. Get all my non-x terms on one side. Okay, and then there we go. So we have our, so I factored out the x. I'm sorry, I think I was just thinking that through my head. So I took out x as a factor so I could separate it from the rest of it. That's how you can separate it, get everything on one side, factor it out. And since this is multiplication, how do you get rid of multiplication? You divide, so you can get that on one side. So hopefully these videos are helpful. Just come in with quick questions before your test and study hard.